Hello everyone. Today we will talk about the CRO WebApp distribution and HTML templating. So first let's overview what can be found within the family of distributions called CRO. The original purpose of CRO was to be a set of libraries for writing microservices. It starts as a small core distribution, providing us with primitives to work with data. And not with just the data, but with streams of data. We have sources of data, for example, bytes from sockets, but in reality, anything which can be represented by Raku's supply type, since for data and transformers to boringly transform the data. On top of that, one can model, say, an HTTP server as a CRO transformer from a socket to a socket, where using raw bytes from the socket transformers in between, parsing requests, handle them, and send responses. So this way, a number of protocols was implemented, such as HTTP, WebSockets, LDAP, but in fact anything can be done this way. Besides, we also have some additional tooling, such as libraries to test our logic or scaffold our applications. And last, but still very important, we have some libraries helping out with the application itself from the CRO perspective. So let's take a look at the CRO web app as a part of this. Essentially, the CRO web app distribution provides us support for HTML templates and HTML forms. Alas, we won't have enough time to look at the cool forms it provides, so let's just set our course for the templating first. Logically, it consists of a compiler for the CRO template language with a parser, code and code generation bits, and some helper subroutines to actually use it. Let's do first the most basic step. Here we see some innocent HTML code. At the first glance it looks normal, but in fact it is not good at all. Say if we have a website with TRC logs, we want to display different dates, not just August 1st. And also, of course, we want to display data for different channels, not just the more VM one. And the answer is to keep the data separate and the HTML separate. And this is where the templating came to the rescue. What you see is a bit of a CRO template. The HTML tag is the same, of course, but instead of a constant data, we see something reminding us of a method called in angle brackets. This is actually the most basic form of telling the template what data we want to render and where. On the Raku side of things, we create a hash, maybe populated from a database, which will be far better. And this is a hash with the most original name ever. In the template file, we already have our code we just saw. And then something nice happens, and as a result, we have an HTML rendered properly. The first nice subroutine is called render template. So it takes a template file path and optional hash to represent our data to expand. It can take some template parts, and as a result it returns us a ready HTML string. And just as you see in the code example, here is the magical intermediate bit we want. The next helper is called just template. Say we have a CRO HTTP router and it serves just one route we see on the slide. So we generate the HTML using our render template helper, and then using the content subroutine belonging to crawl to actually set it as a body for the response with the content type we specified. It sounds kind of tedious, right? And in fact it does. Just using the template subroutine allows us to save this bit of a boilerplate, and we can greatly simplify it. So far I'm sure if you saw any HTML template engines in your life, it looks like just yet another one with some funky syntax. And yes, indeed it is kind of similar. The templates are lazily compiled, the content is HTML escaped, and it also has various logic constructs we can expect from a template language. As a closer for this subsection, let's take a look at one more helper subroutine called template location. Before, we saw the helper subroutines taking paths to the template files, and those paths were always relative. In fact, they are relative to the current working directory. But if there are any template location calls nearby, it means that the Chrome web app will search the templates in these directories as well. So now as a small summary. The Crow template language actually looks very similar to just simple HTML with additional bits of the Raku-inspired syntax. I want to especially note how using this distribution is not required at all if you are using Crow and vice versa. You are free to use, for example, Crow plus Mustache templates if it fits you, and you are free to use the Crow web app distribution and not using the Crow HTTP structure, but still keep in mind that it will be a dependency. If you were careful enough reading the description of the render template subroutine, you saw a remark of the second parameter being a lie. The truth is, it can be any Raku thing, not just a hash. It is just that using hashes is easy for such tasks. When the template is rendered, it is assigned to this initial value path is assigned to the underscore or topic variable, and then using various constructs we can operate on that in our template. So please don't mind the semicolons in this example. And so, of course, the most basic and at the same time the most important thing for us is to have the data for expanding into the template. The first form we already saw in our tiny example before. Actually, it is not so basic and a bit of curious. Say we are passing an associative as the topic. When the syntax of a query is used, the engine tries to obtain the value by the key specified. In this case, it is name. If there is no such a key, it tries to call a method on the topic with such a name to get its result, but if it fails, it just returns a nil and you will get a warning. If the topic is not associative, then it just tries to call a method with the name specified, and if there is no such a method, it actually throws an exception. After that, we can observe some other forms of this syntax. For example, parentheses, they always demand a method call, and the angle brackets, they always demand a hash access. We can also index the topic if it does the positional role, and then the same forms but with variables. And yes, we actually have variables as well. During rendering of the template, variables in the lexical scope of the call to helper subroutines are not available. Yet some constructs allow us to declare variables we will use in our templates. First, let's take a look at loops. Instead of direct writing out our values, we can iterate over the channels here. Inspired by Raku, iteration happens using the array sigil. After a double colon, we see a variable declared called just C with the $sigil prefix, which is then used in bounds of the loop body. Note it is not necessary to declare this variable. One can write a loop omitting the double colon and a variable name after it. In this case, the value iterated will be assigned to the new instance of the underscore variable. It will become the new topic. But see how we are using the date value from the outer underscore variable. So to avoid shadowing it, we declare a variable C. If you are curious about this syntax with the array sigil and where from the channels came, in fact it is just a shortcut for the longer form, it being an array sigil and then the normal topic access syntax we already saw. And if instead of accessing the topic we had, say, a variable called channels, prefixing it with an array sigil results in a loop as well. Also note the closure for the loop body. Previously we saw it being very short, like this way, but in fact it can be longer, spelling out the channels the second time for the sake of clarity. Now we can discuss subroutines and macro. Similarly to Raku subroutines, in the template language we use subroutines to factor out common code and avoid copying it again and again. Subroutines here also have signatures, but they are much simpler than Raku ones. There are also macro in the language, but they in fact have little to do with the actual macro, and so they behave just like subroutines with an ability to pass some expanded template, at least for now. Here we see an example of a simple subroutine. Usually footer is something the same on every page, so we can wrap the code into a subroutine and specify a name. Here it's just footer. This subroutine does not take any arguments, so the empty parentheses are omitted. To call it, we use the ampersand and the subroutine name in angle brackets, which should be hopefully kind of familiar after the Raku syntax. We might note that using certain subroutines can be fancy not just in a single template, but across a number of templates in different files. For this, we actually can include or just use a template from certain paths using appropriate construct shown on the slide. This path is also relative to the current working directory, and the template location routine also affects it. Let's look at some macro now. Say we want a whole page template which is almost the same for different pages, except for a couple of small differences. Instead of duplication, here we just wrap everything in a macro named logPage. As you see, it has a signature with two positional parameters, one topic and the isLife parameter setting the type of the page. Next, we see a body tag. It is a singular tag and it will be expanded into the body passed to this macro. Here we can see a live example of a conditional. To make up a conditional, we use either a question mark or an exclamation mark. The first means if and the second one means unless. So it reads like unless the parameter is life is true, expand the content. Also note the closer. It duplicates the opener tag, so a question for a question and an exclamation for an exclamation. Be careful with the closers. Just as subroutines do, a macro also have a closer tag, so don't forget it. Here we can see an example of using such a macro. First, we import the template file with common subroutines and our macro. Next, we call a macro by name and pass the arguments. Keep in mind the syntax is simplified in arguments as well, and for example, complex string literals are not allowed, only single quotes. The template code between the opener and closer of the macro becomes a body, and so it has expanded by the engine here, and then it's best to be later expanded in the macro itself. Let's take a look at conditionals a bit closer. Here we can see a usage in the wild, just a question mark tag asking something from the topic variable. Keep in mind that it is written with brackets here, which can be used for more complex conditionals, but in this case it can be simplified into something like this form. Of course, it works with variables, as we just saw, as well as with results of the topic querying. Conditionals can be more complex. They actually support basic compare and mass operations. Up to now, everything we saw was quite expected from a template engine. Of course, it is flavored with Raku, but at its core it behaves just as your usual conditionals, loops and subroutines. Next thing we have a bit of time for is a recently introduced feature called template paths. The thing is, so far we saw how one can avoid duplicating the CRO template code by using subroutines and macro. But even so, on the Raku handler side, we still must provide the same data for the common elements again and again. And template paths can help us with this case. This code assumes you have some basic understanding of the CRO router. So first we have our first route. It serves the home page and demands some authentication into the code object. This handler calls a template and asks if the user is logged in or not. If so, their order is passed to the template, but otherwise a nil is passed. In our second route for the page categories, we trivially get our list of categories from the database and then call the template subroutine with an appropriate template. But here we also have to add the user authentication object and then retrieve the order to pass to the template. If we have two such routes, that's fine, but if 2 dozens and they are not as simple, it's time for action. Let's wrap our template code into a new construct called path. It also has a name and takes in this case a named parameter called order. Parameters also can be positional. Inside we use it to access the data we want to expand into the template. Now back to our roots. We call the template part helper subroutine. The first argument is a name which we have to our part in the template, and the second is a block of code. It can optionally take the authentication object. In this case we take it, and then it returns a capture with named arguments, and they can be just positional values as well. Those named arguments then will be passed to the template part. Now let's take a look at our first road. Now there is no need to pass the data to the template part as Crow does it for us. The second page also became a lot cleaner. If we want to overwrite what the code execution returns, we can just pass the parameter parts with a bunch of keys and values, where keys represent part names and values represent arguments to pass. The primary question, I think, is why do we need just yet another template engine in Raku? Why not something else? For this, I can note a number of reasons. First, its syntax is inspired by Raku, and so it can feel like home for some. It is easy to grasp what's happening pretty quick. And then we have integration with Crow with all the nice helpers. Also, it is compiled, so it is relatively fast. In my usages, it was about twice as fast as the other template engines I won't name, of course. This template language is already supported by the comma IDE with syntax highlighting, navigating from paths to their handlers, and other goodies. In fact, it has more features than those I just showed, such as HTML forms, template repositories, the support for the log timeline model, and so on. And also we have more features planned for the future, support of different languages, better diagnostics, and so on. Any questions? All right, so can you hear me? All right, so any questions? Oh, I see there are some. All right, so any session cookies planned for Chrome? Yes, and of course, in fact, it is already implemented. For this, I recommend you to go to Chrome Services docs and open it, and there is docs article about, it's called HTTP authentication, authorization, and sessions. I'll just post a link here and also to YouTube chat right now, and so you can actually, and authorization via cookies is implemented there and already available. Any other questions, maybe?
Yeah, I have a question actually.
Okay.
Crow templates has always looked really great, and I keep wanting to play with it more. You mentioned that it's compiled. Is it compiled into Raku code and like regular bytecode, or what is it compiled into?
It is compiled into, well, not Raku bytecode, but I mean that it is compiled into, dispersed into some kind of AST, and then a bunch of objects are created, and then they are used without any reparsing or anything like that. And because the objects and method calling is already quite implemented for a lot of cases, quite optimized for a lot of simple cases, then it gives some performance boost, I think, compared to just string manipulation.
So if I'm understanding you correctly, it's like JIT compiled for a running server, but if you were using Crow templates to, let's say, like generate a static site, the template itself isn't pre-compiled. It's just that it's JIT compiled for requests after the first one. Is that right?
Yes, I think the second thing you said is correct.
Okay. All right. Thank you. That was very helpful. And great presentation.
Oh, thank you. Okay, maybe any questions from the chat? All right, so do you have any benchmarks, performance comparisons with template mustache? Well, we are also kind of running out of time. Yes, I do. As I mentioned, I saw that WebApp is faster, up to 2 times compared with the ones that were mentioned. But again, it is not in any way an official benchmark. I just, when I was working on the documentation website, I tried a couple of different template engines, and to actually get the fastest page loading speed, I had to use WebApp because others were kind of slower. Maybe it's just me. Again, it can depend on the data, on like how big your templates are, and so on. I think that's about it. If it answers the questions, and great. Anyone else? Do we have time left?
Well, actually, we don't have any time.
All right.
But there's another question maybe you can ask, you can answer.
All right. Do different template engines play nicely together with the Raku API, or will there be problems? Well, it depends on what do you mind with the Raku API. Maybe you mean the Raku AST. Jonathan had a talk about yesterday, but I am not sure. Oh, also I just posted my nick at TRC, and you can find me on LiberaChat. Okay, we don't have time anymore.